Lasers and Fiber Optics, 5th semester CBCS 2020. Under laser and fiber optics, let's discuss regarding fiber optics and dielectric waveguides. Initially, let's see what is a waveguide. Waveguide is a device that can be used to transmit power or signals in the form of waves while minimizing power loss. Common examples are metallic tubes, coaxial cables, and optical fibers. Electromagnetic waves may propagate in space as radio waves, but for many purposes, waves need to be guided with minimum loss from the generating point to the point of application. Several guiding systems are of importance: hollow pipe waveguides, dielectric waveguides, etc. Hollow pipe waveguides are used primarily in the microwave region of the spectrum, whereas dielectric waveguides are used in the optical region of the spectrum. A dielectric waveguide consists of one dielectric material called the core surrounded by a different dielectric called the cladding. The permittivity or refractive index of the core is larger than that of the cladding, and under proper conditions, electromagnetic energy is confined largely to the core through the phenomenon of total reflection at the boundary between the two dielectrics. Earlier, dielectric waveguides are so lossy that they can be used only over shorter distances. Fiber guides are now the basis for a worldwide optical communication network. The most important dielectric guide at present is the optical fiber used for optical communications. In addition, different waveguides are needed to guide different frequencies. For example, an optical fiber guiding light that is high frequency will not guide microwave, which have much lower frequency. So let's define waveguide. A waveguide is defined as any structure capable of guiding electromagnetic radiation in a direction parallel to its axis while substantially confining the radiation to a region within and adjacent to its surface. Principle of operation. Waves in open space propagate in all directions as spherical waves. In this way, they lose their power proportionally to the square of the distance. The waveguide confines the wave to propagate in one dimension so that the wave loses no power while propagating. Waves are confined inside the waveguide due to total internal reflection from the waveguide wall, so that the propagation inside the waveguide can be described approximately as zigzag between the walls. History. The first structure for guiding waves was proposed by J.J. Thomson in the year 1893 and was first experimentally tested by Oliver Lodge in the year 1894. The first mathematical analysis of electromagnetic waves in a metal cylinder was performed by Lord Rayleigh in the year 1897. The study of dielectric waveguide such as optical fibers began in 1920s by several people. Most famous are Rayleigh, Sommerfeld and Debye. Optical fibers began to receive special attention in 1960s due to its importance to communication industry. For example, optical fibers transmit light and signals for long distances and with a high signal rate, whereas a microwave oven, a waveguide, transfers power from the magnetron where waves are formed to the cooking chamber. Modes. When the wave is traveling through a waveguide, the electric and magnetic fields of an electromagnetic wave have a number of possible arrangements. Each of these arrangements is known as mode of propagation. Thank you.